Hi, this is Stockton Maxwell from the Department of Geospatial Science, and today I'm going to run through a quick tutorial on how to use Coorecorder to measure samples for tree ring analysis. So let's start out, open up the software, and we'll do a walkthrough. This is the newer version of Coorecorder as of June 2018. This is 9.31. You may have a slightly different version on your machine, but in general, most of the things will be in the same places. So the first thing we need to do is open up an image for analysis, assuming that you already have some scanned and ready to go. These can be different types of image file types, including JPEGs and TIFFs. So we're going to go to the File menu, open Image for New Coordinates. This is pull out one that I have from Wyoming. And the first menu that comes up, it will look at the resolution of the data set, so the DPI or dots per inch. This should detect the values of the image, and so this was scanned at 2400 resolution. And what we are going to be doing today is doing just total ring width measurements. You can also do seasonal wood or early wood, late wood, and I'll probably cover that a little bit later. And so here we'll use the default measure ring widths. You can also use this to generate other types of data like blue intensity. And so once we just verify the settings, we'll hit OK and have our image opened. And so now we have our tree core here. And actually, it's part of a cross section on this one. And we want to measure the rings. And then because we have an established chronology for this site, I'm also going to show you how to open up a reference chronology to help date against. So the first thing I'll do is go to File, Enable Ring Width Curve Display. And you may or may not have a master chronology aiding you for the site, but if you do, this is a good way to help more rapidly pin down the dates that you can verify later statistically. And so we do have a master chronology here for the species Douglas fir, Pseudotsuga menziesii. This is a .wid file for Coorecorder. Those .wid files can be created in the partner program CDendro. And so we can see the master chronology now graphed at the bottom, and then as we start to measure our rings, those measurements will start to overlap on top of that master chronology, and we'll see if they wiggle together as well as see how well they correlate. Okay, now we need to begin measurements. I'm going to use the zoom in tool and zoom into the beginning of the pathway. You will be measuring from the bark inwards towards the pith for this measurement. To start measuring, we are going to enter what's called the data picking mode by selecting the D. And I am going to select this first ring right here. You want to hit the boundary of each ring, and the idea here is that we want to measure perpendicularly across each of the tree rings. So it's the shortest distance from the beginning of one year to the end of that year. And so that asterisk symbol symbolizes the first year of measurement for our tree ring series. Now we could go in and continue entering ring paths manually, or we can use the auto place function, which I highly recommend for conifers. And so we will go up here to the auto place points, select that. You'll see this message come up. You want to set your enclosing points, so the beginning of where you want it to detect points to where the end. And I'll click Don't Show This Message again today because it'll keep popping up as we do the analysis. So I'll just do a few rings at first, and then I will show you how we can do other things like shift around. And so just below our first point that we marked there, our first year, we can begin the path, and I'll just go down a few years right now and hit end. And what it has done is it's looked at the lightness and darkness of those pixels and marked a boundary where it sees an abrupt transition. So you'll see it does pretty well up here, but because we have some rot in this wood sample, and you might have this discoloration of some sort, it will try to mark boundaries of other sorts. And so what I typically do at this point is use my arrow here, and I can go and select points that either need to be deleted or moved. This number 10 ring is clearly not a ring boundary, and so I'm going to hit the delete key, or you can use the X delete kill button at the top. Same thing with number 11 here. I'm just going to go ahead and hit delete and remove that point. And so what we're looking at now is our beginning of our series being measured, and we want to continue down the pathway. Because there's a little bit of noise here with the rot, I'm going to try to shift over to just outside of this and go down the side to avoid a little bit of that. And this is actually a pretty straightforward operation once you get used to the functioning, but we will go back to the data picking mode. And instead of this single dot, if I toggle that, it'll show the 3 dots. And what that allows to do is when I put in this next point, I can click it, and then I can shift my pathway over. The advantage of this is that you can shift your pathway and it won't measure between those two shifting points. Now I can continue down through this pathway with another section of auto place, and it won't measure through that shift. This is pretty handy when you need to move around a sample to avoid damage in the wood or other disturbances. And so we can go down through and add in our new points. Go through quickly here and clean up by selecting and deleting. And that's functionally what you need to be doing throughout the entire core. What I'll do is continue measuring all the way down through so you can see the entire process and deal with any errors that occur along the way. So I'm going to zoom out using Control-Z and use my arrows to shift the image up and down. That's a really nice navigation feature with the arrows. Otherwise, there is the hand tool up here at the top that you could use if you'd like. Looks like we have a pretty good pathway through here, so I'll measure the next section of rings with auto place. But we do see is that we have a little bit of a transition where we get a little bit on an angle. And it's just slight at this point, but that will compound itself as these rings become more diagonal, and you would measure diagonally across those, which we don't want to do. We want to make sure it's perpendicular. And so from here, I will auto place again. And what you can do is you see the lines, you can kind of use those as guides to make sure that you are moving perpendicular across the ring boundaries. So I'll go all the way down through here. And I am picking up those ring boundaries pretty well. Scan down the image. You can also place points manually, and let me just briefly show you how to do that because you may have trouble sections that you want to move through. I'll do another quick shift here by toggling this switch. You can also use your right mouse key if you need to, and that will toggle between single point and that shifting point type of data point method. So I'm going to actually shift across the line again, so I'll mark here, and then I will shift over here. Now let's say we wanted to do some manual work, but sometimes it's hard if you put in individual points to stay straight. You know, you're trying to as much as possible, but it can be difficult. You go off a little bit. And so you can add this help line right here. And so if I click on this tool, I can add a help line to move down through here. And this is not actually doing any measurements. It's simply putting a line. So when I do add in my points, I can stay along that pathway. Now you may need to zoom in here, either using the Z button or using the zoom in arrow. And I'm just going to zoom in so I can see my boundaries a little bit better. And go through and enter my ring boundaries. You just want to make sure that you are careful with marking the ring boundaries because the hallmark of dendrochronology is accurately measured and dated wood samples. And so we are dependent upon accurate measurements from ourselves and from our technicians. So you can see as I click, it is building my graph down at the bottom, and we are beginning to see the measurements move along. And you can see that it doesn't necessarily line up with the master chronology. This is a dead wood sample, so we don't know when it dates. I'll just continue going down, and now I'm going to just speed things up a little bit and move through this. Change my angle here. And let's keep going. Oh, want to try to maintain that perpendicular motion across the ring boundaries. Keep on auto placing. You could do large sections at once if you'd like. I tend to do around 20 or so rings at a time, depending on the quality of the sample. But there's no problem with going through and inserting these like this. So we're getting close to the end, and I'm just going to insert these last rings manually because of the the changes in the coloration of the wood. And there we go. That is our last ring boundary. I could shift over one and grab this last one as well, and maybe I'll just do that. Delete that. I'm going to toggle between the single point and the multi-point, and this will allow me to mark this ring boundary and this ring boundary. So you eke out every year possible in the sample. So now that we've measured everything, I would go through and scan up the core to quality control my ring boundaries and check to make sure that I have them in the right places and that I've hit every ring boundary and that there are not additional markers in there that are not true ring boundaries, because that will mess with our dating. And so we're looking pretty good here. And we have a measured sample, relatively short in age, just about 105 years. But we can use the statistical portion of Coorecorder to help us date that. And so down here, I have clicked for correlation C, exclamation point. And right now, it's showing me that I have a correlation coefficient with our master at the current dated position of 0.01, which is clearly not good at all. It's showing really no correlation at all. We'd like to see that go up to 0.4, 0.5, even up to 0.7 with some of these samples. The middle factor here is called the t-value. This is just another measure of how these two series match together. And you can read a little bit more about that on the Coorecorder help website. And then 104 years there, that's the number of years of comparison used in that correlation analysis. This is actually a button, so if we click on it, one of the great things about Coorecorder is it will shift the series to where it has the best fit. And so here what it's done is it's positioned this with the outside ring of 1884 and an inside ring here of around 1780. And what I do is I look for this correlation now being 0.62, very high, and I look to see if the major marker rings are fitting. And so you do this in place of potentially the more manual method of skeleton plotting. This is a visual version of that if you have a master that you've already built together. And so we can see that this matches up really well. The lines are wiggling together. Those narrow rings and wide rings are matching up well. And we have a strong correlation. And so I would consider this sample at that point dated in a preliminary manner. And then we would check it statistically either in COFECHA or DPLR. Now, let's make sure that we save our file here. And so we are going to save the coordinate file. And it will give you this message that you haven't defined your distance to pith. With some samples, you may want to try to estimate how far away from the pith that you were for ecological purposes and to get a more accurate age of the tree. For these climate reconstruction cores, we don't necessarily need to do that. So I'm going to hit remove distance to pith. And then I'm just going to save that core as BTKX03A. That's the name of the sample. And I do have a measurement in here and from before, so I'm just going to call this one test so I don't copy over. So now that we've recorded it, that sample is dated. One other thing that you may have to do is if you want to adjust the date of the rings, and you can see that the data or the decades are now marked along the tree core, which is really nice because we can start to clue into where there might be key changes in that tree ring growth pattern. But we may want to change that outside date. You would go and select that outside year, that asterisk, and we can go to the More menu and set year Y of that selected point. That menu popped up over on the other side. Let me drag it here. So it's dated to 1884 because we did that correlation shift. If it was a different date that you might want to manually enter, you could do that here. Or if you were dealing with the first measurement in a whole new chronology, the first core, you might know that you cored that in the year 2019, or the last growth year was 2018, and you could mark that in here now for all of your new cores. That way, when you build a master chronology to then begin comparing against, it is a well-dated, anchored chronology in time. So that's just if you know when you core those trees. With these dead samples, we don't necessarily know, and we let the statistics help us get a first idea of where that date will be. So I'm just going to hit OK here because we have the correct date. So that is the key function of what we're going to be doing in Coorecorder. Some of these samples become more difficult, so you have to make sure you adjust your ring boundaries a little bit more appropriately. But quality control is key. You want to make sure that these samples are well measured so that we can make sure that they will be subsequently accurately dated. If you have any questions, feel free to contact me, rmaxwell2@radford.edu, and I will help you out. Thank you. One last quick thing, just so you've got all of the basics in. If you need to close this file, you're probably going to want to know how to do it and open up a new one. We're going to go to File, and we are going to close the coordinate and the images. You may want to put a second radius on a larger cross-section, and so here you could just close the coordinate file and then start a new pathway on that cross-section and create a new POS or position file. Because we're finished with this sample and we're only doing a single radius on it, I'm going to close both the coordinate and image files. Save before closing, and again this menu popped up, remove distance to pith, and I'm just going to make sure it's saved over completely, replace it, and we are good to go. It's going to close it out. If you're moving on to another sample from the same site, leave open your graph down below and you can just go and open another image for new coordinates. Okay, that's it for right now. Thanks.